When we think about how our apps and networks are built, we usually picture a static blueprint. But a live digital system looks like a massive warehouse in constant motion, with thousands of packages shifting and moving every single second. Defining the architecture of a database sets up the empty shelves, but the live functionality of that system depends on how you handle the data flowing through them day in and day out. That constant state of change is controlled by Data Manipulation Language, or DML. It is the toolkit that keeps every banking app, social network, and corporate system functioning in real time. And it all relies on 3 specific commands: insert, update, and delete. Mastering these commands allows a programmer to modify a system's live state in real time. This level of access means a single typo can overwrite years of corporate records in an instant. The lifecycle of any piece of data starts with creation. Let's say a company hires a new employee. That person officially exists in the real world, that now we have to add their record to the digital system. This slide outlines the syntax to do that. Start with insert into, the target table name, then the values. You have to wrap character strings and dates in apostrophes, while numerical entries are entered directly without them. This second code block shows how you handle that. You use the word null as a formal placeholder to keep the sequence structurally intact. There is no room for interpretation here. The database is entirely rigid, and it will flat out reject any insertion attempt that doesn't fit its exact expected mold. Once data is in the system, it ages quickly. When an employee earns a promotion, you can't just delete them and start over. Their existing record has to evolve. This is where we use the update command. As this slide shows, you specify the table name and then use the set clause to dictate the exact columns you intend to modify. Looking at this code block, we update the staff table by setting the position to manager and salary to 18,000. But the most critical part is the final line, the where clause. This targets the changes exclusively to one employee, SG14. If you execute an update but forget to include that target clause, the database doesn't ask for confirmation. It simply overwrites everything in its path. By leaving off that single line of code, the system defaults to updating every single row in the entire table. You will have just accidentally given every single person in the company a manager's salary. There is a rare scenario where you actually want this to happen. This slide shows an intentional mass update, applying a flat 3% inflation raise to the salary column for every single row in the database. Used correctly, the update command is a precision scalpel, but without that where clause, it instantly becomes a wrecking ball. Eventually, every record reaches the end of its usefulness, becoming permanently obsolete and needing to be removed entirely. This text defines the final core command, delete from. And just like with our updates, the where clause is the primary tool used to lock on to the specific record you intend to erase. It's vital to clarify exactly what happens next. Executing a delete command destroys the contents of the row, the paper inside the folder, but it leaves the overarching structure of the table entirely intact. It sweeps the old stock out of the digital warehouse, leaving the structural shelves completely secure and ready for new data to arrive. While you build a database structure once, DML is the mechanism that handles its daily operations. This trio of commands provides the tools needed to add new entries, modify existing ones, and remove those that are no longer necessary. To manage this safely, you have to follow the formatting rules perfectly and always use null instead of guessing at unknown values. Most importantly, never execute an update or a delete command without verifying exactly what your where clause is targeting. Managing these systems requires precision, because to a computer, the status of the world is defined entirely by the state of its data.